Hey everybody, this is Larry. This is day 23 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Threesome with multiplicity. Yeah, I can't even say it. Okay, given an integer array, target ijk, so that I times j times where's the so they're dupes is what it's saying. Okay. Is it sorted? The inputs here are sorted, but it doesn't seem like it needs to be sorted. Uh, Let's see. I'm trying to think how to think about this. There are a couple of ways to do it. That's why, and yeah, there are a lot of ways to go about it. The key, maybe one thing to know is that the array of I is less than 100 and the target is less than 300, right? So we can actually just use dynamic programming probably. Well, where basically you only have to care about 300 times 300, yeah, 300 times 3, right? Basically the number of numbers used and the current target. I think those are the only thing that we need. Yeah, and if you do it naively, it could be and if you just do it an index, if you do it bottom, if you do it tops down, then it'll be 3000 times 300 times 3, which is maybe fast enough in Python. But yeah, let's do it that way. I mean, if it's too slow, then we'll have to convert it. Yeah, so let's just say total is, or we can just return count of 0, which is the index, how many used, and then the target, right? And then now we have a def count. Like I said, it'll be index, it'll be used, left, or maybe we'll start with 3, so that because we could use 3 numbers, and then target. And then the answer is, yeah, if target is equal to 0 and left is equal to 0, we return 1. Otherwise, if index is equal to n, return 0. These are just base cases for the recursion, and this is the length of the array. And then now we have a number. We can either use it or you don't. So yeah. So total is equal to 0. Total we added to count of index plus 1, left minus 1, target minus array of index. We have to do some boundary checking just so that, yeah. If array of index is less than or equal to target, and left is greater than 0, yeah. And we could also just not do that, so yeah. So that's basically the answer, I think. And we didn't mod it yet, I know. We'll mod it. I just want to kind of check it real quick, because sometimes I get these things wrong, really, because it's sometimes you double count by accident, and or undercount depending on how you do it. So I think that's actually a thing that you have to be careful about, and I'm always a little bit sketched, especially when it comes to having duplicate situations. Okay. Oops. Okay. So why do I have this wrong answer? I expect this to be right if this is right, unless I'm, oh, well. I mean, that wouldn't change anything, but let's see. 3, 2, 1. No, that should be okay. Why is this wrong? That's odd. Two, three, three, two, two. Yeah, I mean that seems like it would be. Oh, no, I mean that still should be okay. Huh. I mean, I forgot to cache, but like I said, I wasn't worried about that yet. Let me see if I could, maybe this answer gives me a little bit more of an insight. Hmm. That's weird. I was going to do it the other way with the other dynamic programming, but did I do it this way? Did I do it in the wrong order? Maybe I did it in the wrong order. But I actually expected this to overcount more than undercount, so maybe I'm missing something really obvious. Let's try something silly. So I am definitely missing something quite obvious because, you know, this should give me a 1. So maybe I have something wrong with my edge case. Oh. Yeah, this is awkward. I think that's why. I mean, maybe I did something. Well, this shouldn't matter though, right? Because we're still undercounting. Why is this undercounting? Does this not go to? Did I miss this one? 0. It's 1 0 1 2. That is really weird. But at least that's a good thing in that it's clear that it's wrong. So once we fix this, hopefully we get a little bit better about it. Yeah. So it goes to 0 3 3 3 0 0. Yeah. Oh, I am okay. Okay. Wow. Order of operations. Okay. So let's see. Yeah, like I said, I actually expected this to be right, but that was just silliness and I didn't even notice it. And yeah, let's see. Let's see if this is right first, and then, you know, we'll have to cache if it's right, because it'll be too slow. Cool. Yeah, okay. So I was, that was just a silly mistake. That's good. I do worry that this will be too slow even with the caching, because this is, you know, but let's give it a go. So the way that I usually do caching is a little bit different than I would do in a contest. If I was in a contest, I would use LLU cache or just cache around your library so that it memorizes the function, because for every input the output is the same, so that's why it works. But let's make it actually let's just do it that way, because yeah. So this is basically the way that I usually actually do this a different way with respect to caching and education, but today I'm a little bit tired. I don't know, so hopefully it's right first. It may be still too slow, to be honest, because I think it's not. Oh. Huh. Oh. Okay, fine. I was thinking about that edge case being a little bit dubious when I was doing it, but that's why I'm able to find it so quickly. But that was just a silly default on my part. Let's submit again, see if it's fast enough. It may not be fast enough because this has too many inputs, but yeah, so that's what I was worried about. That's why I wanted to kind of do it this way instead of writing it out. Yeah, so this is bottoms up. Oh, sorry, this is tops down. And I actually almost never, or not never, but like for pseudo polynomial problems, I almost never do it tops down. But I just wanted to kind of go over the recurrence. So hopefully this makes sense. Maybe I should have taken a big case. Would this have been fast enough? I don't know. I think it's just one test case is probably fast enough. It's just like the summation of many test cases make it too slow. See, because it takes like 1 second and it's hard to tell. But yeah, but I actually would do this bottoms up so that it's a little bit, so it's a lot more faster because it's more space efficient. And the space usually doesn't matter except for you have to allocate memory and fetching it and stuff like that, which LU cache has some caveat to that. But yeah, so that's Yeah, let's do it. Yeah, so dp is equal to do for so we want target for the range of 3, right? So now we want our state to be 3 for 3 sums, and target, which is just the target. I mean, from 0 to target inclusive, right? So then now you have something like, well, we want 0, 0 to be 1. And then now we go for x in array. So for each number in the array, I'm actually skipping a step. So yeah, so one thing to know, and I'm skipping it a little bit, I'll put a link somewhere for my dynamic programming tutorial for going over how to convert it from top downs to bottoms up, and then from bottoms up with a space optimization. I'm going to skip a little bit on the space optimization part. And yeah. How do I do it? Okay. How do I want to do it? There are a couple of ways to do this space compression. I'm just going to do it this way. Yeah. So then now for each number, we can have a push thing where for I in range sub n, for j in range sub target inclusive, if PDP of ij is greater than 0, and x plus, wait, I is in j, but this is 3, sorry. I was kind of confused. Yeah, and actually we want this to be from 0 to 4, because we want 0 to 3 inclusive to store the results. Okay. So then now with x of j is less than or equal to target, then we set dpi of j plus x. We add that to this mod, to the mod. Oh, I guess we do the mod afterwards. And then at the very end, we set dp is equal to p. Oh, sorry, the other way around. PDP is equal to dp, and then dp we set this equal to we reset it, so we just copy and paste this, I guess. And there way, I mean, I know that technically I still allocate a lot of space, but depending on how you want to define space, we'll talk about it in a little bit. You could actually write it in a different way so that you're guaranteed on the space a little bit better and not wait for garbage collection. But I think this is a little bit easier. But basically, this is just, setting previous, setting previous to now, and then update now, right? And also I missed one, which is this is I plus 1. Yes. And then now we just have to get what do we want to get? Well, we want to get the count. So we want to I think it is okay enough to just have sum of 3. Oh wait, no, it's 3 and target. So okay, so we just TP of 3 and target. Mod it just in case. Why not? Let's give it a spin. See if that's good. Maybe I have typos. Or just zeros. Yikes. How am I missing this? Dong dong dong. Oh, why is this x? Oh no, x is right. Okay. That's weird. Okay, let's see this real quick. Well, let's remove this thing because that's gonna be too fun to print. I think this should be mostly right, but so 0, 0. Did I mess up an index somewhere? Oh, I see. Because the reset is wrong. With the reset, we can still set. We don't. I missed one step, which is that yeah, which is that dp sub ij we added to the previous ij because this is the not doing it step. That's why something felt a little bit weird because you know, you remember from the top down, we did two operations. Like we may have had two choices. One is to use the target, one is to use the x, and the other is not to use the x. And I forgot one of them, and I was just like, something feels missing. But yeah, okay. Well, it's still wrong though. But So this is push. Wait, what? Where is this wrong? All right, let's keep it stupid simple with this case, and then we can print. Yeah, really rusty on the bottoms up query. Might have been the syntax though. Okay, so this is after one iteration. That looks good, that looks good, that looks good. So why is this? This looks like it has the right answer. Am I just returning the wrong thing? 3 is 1, right? Why is my answer 0? Did I return the wrong thing? Oh, because I reset the thing afterwards. So actually, no, this is the previous. Whoops. And my computer is being really awkwardly slow. Technical difficulties. Dong, 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 dong. I clicked on the button, right? Oh, there we go. Finished. Okay, so that looks good, or at least better. Now we don't have to print anymore. I am very sloppy today. Oops. But let's at least see that this works for this one. And then maybe the 0 case, and then we'll go. Oh no, this is wrong. Let's try the examples then. I was more confident about this one, but maybe I have, like I am very careless today on the dynamic programming. I mean, I did say I was tired. They gotta stop making these at 3 a.m. because poor Larry from the East Coast is clearly not the best. And my computer is being really slow, and I don't even know why. I don't have anything open. Do I? Sorry, friends. Technical difficulty. But this thing is on, right? Is this thing on? Okay. Let's see. Oh, there we go. It finally got printed. And I think the answer is 8. Oh, 4 instead of 20, huh? What did I do? Did I miss something? Should be right. And then here we just set it to the previous. Wow. What is yeah, the number used and then the number. No, yeah, I mean that should be the same. We just don't use the number, right? Yeah, no, I mean this should be right. Huh. Why'd I only get 4 then? Alright, we'll have to print it out again. The magic of technology. Okay, so okay, 1, that's good. There's 2 ways to get to 1, that's true, and 1 way to get to a 2. Okay, 1 way to get to a 5, is that true? No, that's a 4. Okay, I buy that. So what is the 1, 2, and 5? Where's the 5? Two ways to get to 1, 2 ways to get to 2. Yep, that's right. What was the answer again? 20? I mean, the one way to, okay, using 2 numbers, can I get to 1? Yes. Get to 2, yes. Get to 3, the 2 ways, is that right? Yeah, and then 4 ways, I agree with that. Okay. And well, something went wrong here because it became smaller. Oh, oh man, I'm silly. The reason why is because, and this is by choice. I don't, because before I did this thing, I'm just being silly. So I had to copy over the 4, but I have to do I plus. I thought I was being clever when I was doing it, but so that I could miss an if statement. But then when I add this, I forgot to add the I. Update the I to do it. Yep, okay. I am, wow, just really sloppy today. Sorry about that, friends. Let's test this case and then we'll maybe call it a night. So yeah, so this tells you that, sleep matters. I've been sleeping a little bit early, but that means that these little later things are a little bit annoying. So that's good. You can see that the time is much faster, though it's still not as fast as I would like. But it just should be okay. I mean, if not, then we're just gonna have issues. Or maybe there's a very easy algorithm that I'm a little bit silly about. Okay, cool. Yeah. So what's the complexity, right? Well, as we said before, the time complexity is gonna be index, or like for each element, so it's gonna be n times I n times j. So that's the beauty about bottoms up, is that it's very easy to see the space and time complexity. So the time complexity is n times 4 times target. So this is going to be O of n times target. And in terms of space, it's just going to be O of target times 3, I guess, if you want to, or times 4, which is O of target, obviously, for space. But yeah, I would say, I mean, I know I struggled a bit on this video, but this is actually relatively a easier version of the dynamic programming, which is hard for me to admit after stumbling on it. But I mean, I knew how to do it. I think my implementation's been terrible, and that's why maybe I need to practice more bottoms-up dynamic programming in Stream in the future. But yeah, hope this makes sense. Let me know what you think. I think in other languages you could probably actually even just use the n square way with with counting and maps and stuff like that. But in Python, it probably was a little bit sketch. This is the way to go. And let me know if you have any questions. I mean, this is a little bit late in the March. This is a little bit more difficult problem if you haven't experienced it, but it is a very common pseudo polynomial dynamic programming solution. So I definitely recommend you get familiar with it. Here's the code. let me know if you have any questions. I might not have been. I don't know, I probably need a little bit more sleep. This is too late for me. As you can see me making all these mistakes, but I hope that it helps. That like I said, hope you get enough sleep. But also just like in general, even when you know how to do it, sometimes you when you're a little bit out of practice, stuff happens, and you try to be too clever and try to be too cute. But yeah, that's all I have. Let me know what you think. I will see you later. Have a good night. I hope I will have a good night. And yeah, take care of yourself, to good health, to good mental health. And I'll see you later. Bye bye.